Okay, everyone, here we go. We're going to talk about this time a 5-factor 2-level, so 2 to the 5 design experiment that we're going to try to do. And so the background on this one was they're putting a website together, and what they want to do is they want to have people go through this stuff and try to figure out what makes people actually sign up and subscribe to this this website or whatever that they have on here. So they have different variations of all of this stuff between a page color, button text, image, and then like is there a testimonial on there? Yes or no? And so so each thing is a little different. You have the page color being white and black. Your button color is orange and green. Your button text is actually sign up or subscribe. Those are the two options there. The image is either of a man or a woman, and then the testimonials, is there testimonials present or not, yes or no? And then so that will then get you your conversion percentage there that goes with it. So again, just like the last one, it's very similar to the last one actually. And so you'll go DOE, factorial, pre-factorial design, 2-level, and you have 5 factors on this one. So again, going back here to you have 5 factors, and you could do a full one at 32, right? But if you wanted to do a 16, which is the level 5 there, you could do a half, and so that's half of 16 is half of 32, 5 level with 5 factors with a resolution of 5, and you can choose that one instead. So knowing that, I'm going to go to my designs. There was nothing. There's 8 that has a resolution of 3. We don't want to do that. We could go full factorial on that one through 32, but we want to be efficient on this one, and we only want to go with the 16 runs, the resolution 5, which is the 2 to the 5 to the 1, 2 to the 5 minus 1. So that's what we're going to select right there. It's just that. So from there, the factors, now I have to type in each one, and I'm going to try to do this as fast as I can, but this one is page color. Oops. And then each of these is going to be a text. So each of these is text because it's not numeric. And then the high and the low is, this is page color, so it's going to be white. And then the high is going to be black. And then your next one is button color. So the color of the button on the screen. It is also going to be a text. We're going to go orange, and then green. And it's going to go button text. It's text. So the 2 levels are sign up. So again, this is nothing numeric on this one. So it's just a different way of looking at it as well. But and then the next one is the image. So that's either of a man or a woman. We'll go text. And then we're gonna go and ooh, yeah, look at that. And the next one is testimonials. Text. And it's either yes or no. And so that's how you set up your design factors. Your options, again, on this one, we're not going to do a randomized run. Normally we would, but we're not going to on this one. The results are fine on this one. And then that is our design right there. So going over it, you got 5 factors with 16 runs is exactly what we wanted. The base design is going to give you the 5 factors with the 16 16 runs there. No, it's just the one replicate. It gives you a resolution of 5, and you should always be double checking to make sure you get your resolution right, which is a half fraction. So here we talked about design generators. Here is your design generator, which is the E is equivalent to A, B, C, D. And there's your alias structure. So you have all of your confounding terms together there. So, and we talked about a level 5. And so that's why we have, terms of 4 and a 1. Sorry, yeah, it was resolution 5. I forgot for a second there, but yeah, so 1 with a 4. You've got some 3 with a 2 interactions, and so that's what that looks like. So you know right away what is confounded and what's not there. So past that. I need then to go back to worksheet 1 and get the conversion percentage out of there. So I'm going to go here. I'm going to go copy cells, go back to worksheet 2, paste that there. If I paste that, oh, whoops. Sorry, this is easier said than done. So copy, then you just copy the whole cell. Paste cells. And so I'm going to go straight into stat, DOE, factorial, analyze factorial design. There's only one result in there, and that's that conversion percentage and of what factors created that. Going into terms, there's a default on here that the only terms that are going to go through are the terms to the second order. So the terms you're going to see in here are all your your main effects, your A through E. So each of those, and then your interaction effects of the AB all the way through DE. So all your two-way effects, like we talked about, three-way effects most of the time are not a huge deal. So it's not a big part of usually what we do anyway. So only having them in 2 there, you can't really go much more. You can't go more than 2 because of the fact that you can only just fit so many terms in there. So those are all your selected terms. We went through 2. Being that it's fractional, you can only go 2 on that one. So we're going to push OK. Options, no, sorry, nothing there. Nothing on the stepwise. Graphs, a lot of times I just use the 4 and 1. But you could choose just which ones you want there. Results, nothing in there that we got to change. And storage, you can do residuals too, and we'll talk more about residuals at some point too. But that's where we're going to stop right there. And so we go into, okay, so here is our design and the analysis of the design. So what you see here is, again, so this is your coded coefficients. So you have no p-values here because in a fractional factorial, there's just so many of the terms are taken up by all of the extra interactions that go with all that stuff. So for that one, we do not have a p-value, any p-values to give us statistical significance off of that one. On this model summary, our R squared is very high, so it does talk about any variation and it models it very well. And the ANOVA portion of this, again, no p-value at all. And then you do have the regression here that can give you the prediction model of what could actually have an effect and have us, come up with the the formula for trying to do a prediction on that one. So, but again, we're going to talk more about regression in the coming weeks here. So here's your factors, your alias structure. So you have all your factors right there, and then all your aliases, so confounding terms. So in this design, and so how do you get this without having a p-value? And so because there's so many different terms and that kind of thing, what you have here is you have this you can see your p-value that would be based on what the p-value would be at the at 0.05, right? So whatever your alpha is. So that's what your estimated p-value would be. Excuse me. And so you have that based on this, and this is based on the Lentz PSC, which is Lentz pseudo. Oh man, what? I'm trying to think what that stands for again. I wrote it down here. Stop. I'm on video. I'm on video right now. So, all right. Pseudo. Oh shoot! I even wrote it down. I can't find it right now. But anyway, so it's just a model that you can use to try to figure out what two terms or what terms do you have that would be statistically significant. And in this case, it's you're looking at A and D. So page, color, and the image for this model here. So again, we could go through the stepwise version of this, but I'm just going to go back. So I'm going to go Control E. Remember that it's AD. So I'm going to go back and I'm going to go in terms here. I'm going to get rid of all my terms. And I'm just going to go back through with the A and the D. So your terms of AD. I'm going to say OK. And then I'm going to do everything exactly the same. Now we are only talking about two terms so that we have more degrees of freedom that we can figure all of this stuff out. In these terms, you can see right away the p-value for the page color and the image are both 0, so significantly statistical that we have in here that those terms are statistically significant. You see the model summary, you're in the 80s, so it's a decent representation of the variation in the model. Your ANOVA, talking again, same thing, the page color and the image there, both statistically significant. Now you can have your conversion percentage, so you can have your regression model, so you can make a prediction off of that by using this calculation here. And then I'm gonna go over the fits and stuff, but so alias structure, you still have your alias structure in here, and then you get into exactly what you want to see. The Pareto chart for the standardization effects in in this model. Again, you have A and D being that it's the image, page color and image of this model here. And so you can see your residual plots for conversion percentage. And again, this is looking really normal as long as it fits the red line. And this is, pretty normalized data right here. And everything else is, it looks very normal and random. And so all of that stuff works pretty good. One thing that I probably should have done, a lot of times when you do this, you don't just reduce the model right away, but you would go through each step. And the first step you would do, knowing that you only had A and D, you could go back through and go all your single effects. So all 5 of your single effects you would put into the calculation, and then you could see that. But again, it's as easy as this. It's going through here and just get rid of everything that's in there, and then just picking your 5 single effects. Oops, did the wrong thing there. Those, and then just, so you pick those 5, pick that, and that's okay. And so again, you could look at it again, and it's only, again, page color and image that are statistically significant. Everything else is over the 0.05 alpha range. And so, again, going back to here, you're still looking at that as being the only 2 things that are really significantly statistically significant in creating the conversion percentage that we want to have at the end of the model there. So the one extra thing that you can do as well, you can go get some extra graphs. And again, you could have done this with the last one too. I just didn't do it, but I just wanted to show you one more thing. But you go to DOE factorial, and you can go to factorial plots. And so you have your response, your page colors. I'm trying to think what else you would have to have in there. I think it's just straight up okay. And then this gives you your main effects plots for your conversion percentage. So again, what's the statistically significant ones? Page color and image. So this shows a very solid understanding of when you have the higher conversion percentage here, you have the page color being white and the image being a woman. And so that's how you would see what things really have an effect on your conversion percentage there. And so another way to be able to show it is your main effects plot that goes with that. So anyway, that is as easy as it is. I hope that helps you guys out quite a bit, and we'll catch you on the next time. See you.